Welcome to our density project. My name is Dylan,
My name is Antonio.
And I'm Jose.
and we are part of group 7. For question number 1, we were talking about volume. Volume is given in the formula length times width times height. And before doing that, since the table that we were given was in millimeters, we are going to have to convert to centimeters. Block 1, this is the math. So you're going to take it, and then there are 10 millimeters and 1 centimeter. So you are taking the millimeter number that you had before, dividing it by 10, and that will give you centimeters. So you have 5.499. And that is going to have 4 significant figures because the original answer did, and you're not using the significant figures in the exact value. You're going to do that for the other 2 numerical values that you have, and then this is what you're going to get. Once you do that, you multiply all the values together, and you're going to write down the exact answer, every single digit that it gives you. You're going to locate the lowest amount of significant figures because you are multiplying, so that's going to be 3, and this answer right here. So you're going to have 3 significant figures in your final answer, and that's going to be 5.44 centimeters cubed. You're going to do this with each of the blocks that you were given on the table. So again, here's the work here. It's important to pay attention to the significant figures that you have. Remember, don't get confused by the exact value. I have the answers right here. For block 2, again, multiply it here. The lowest amount of significant figures is 3, so you're going to get 9.89 centimeters cubed. Block 3, again, the conversions. Pay attention to your significant figures, the values. As well, it is really helpful to include your labels when you are doing the equations so you know exactly what cancels out and what you're converting to. Block 3, again, you're going to have 3 significant figures as your lowest because you are multiplying, and then you're going to get 13.3 centimeters cubed. And then lastly, block 4, same thing, paying attention to significant figures. This one has 5 significant figures, so it is a bit larger than the other ones. And then again, 3 significant figures is the lowest when you are doing the calculation, and you write your whole exact answer, and you're going to get 19.3 centimeters cubed. For question number 2, density is determined by mass divided by volume. It is represented in this question as grams centimeters cubed. You're going to take the mass that was given for block 1, and you're going to divide it by the volume. And then you're going to notice there are 3 significant figures right here. That's the lowest since it's division. And you're going to have 3 significant figures in your answer. So you're going to get 2.70 grams centimeters cubed, or per centimeters cubed. Again, make sure you write out the whole entire answer so you know if you need to round up or not. This is the work for block 2. You're going to get 2.71 grams per centimeters cubed. Block 3, again, 3 significant figures, 2.70 grams per centimeters cubed. And lastly, block 4. Again, mass divided by volume, write the whole answer. You have 3 significant figures, and that is going to give you 2.72 grams per centimeters cubed.
Okay, and then to find the average density, we went off with Dylan's numbers. So block 1 being 2.70, block 2 being 2.71, block 3 being 2.70, and block 4 being 2.72, and all values being grams over centimeters cubed. And then in order to find our average, we have to add up all 4 of our values. Ended up being 10.83, but with the rule of sig figs, we have to do the least precise since we're adding, which means that we're rounding to the hundreds place. And then you divide by 4 since we do have 4 values, and the average ended up being 2.71 grams over centimeters cubed. And then looking at our graph, okay, and then so I put as our x values as, or our x variables as our volume being 5.44, 9.89, 15.3, and 19.3, and the y variable being our mass. And then we also put our density values on there as well. And for the mass, we went up increments by 20. And for our volume, we went up increments of 2. And then we also included the line of best fit. And the equation that the line gave us was 2.72 as our slope and also as our average density for the graph, plus negative 0.175, and the r squared being 1, which means that our graph was 100% accurate on that.
All right, thank you. For number 1 in part 2, the question states, when you add the trend line to the graph, an equation of the line, the slope is the average density. State the value and compare it to the average value for density that you calculated. Why are the values slightly different? Oh my gosh, sorry. So for our graph, for our average density, we have 2.72 grams per centimeters cubed. And then for our original calculations, we have 2.708 grams per centimeters cubed for our average density. Values are slightly different because the trend line in a graph that creates the equation only best expresses the relationship between the points without necessarily covering all the points previously determined. It may also be referred to as a line of best fit.
And the values are also spread out. You see this?
Yeah.
Oh yeah, and the error we made procedural errors and errors in the calculations. Something happened in the graph where the slope was set, 4.7, and the calculation for that was, it ended up being like this. In the calculations where we subtracted it, we got like 1.99, just 3 sig figs, and then when we divided that by 2.710, which was given in question 4, and then we multiplied by 100, and then we ended up getting 73.4. That's wrong. The actual calculations, when the slope was 2.72, and we subtracted that by what was given number 4, which was 2.710, and we ended up getting 0.01, 1 sig fig. And then we divide that by 2.710, and we multiply the answer by 100. We need to get 1 sig fig, and then it ended up being 0.4. That's percent error.
All right, and that's going to be it for our density project. Thank you for listening to our presentation, and I hope you learned something from the video.